Hi guys. So I'm making a struct that is derived from true type for specializations where, well, expression 1 is less than expression 2. Not based on values, rather based on yeah, something else. What this requires has to describe when E1 is less than E2. That is difficult. Each product exists of two factors. I guess I'll just compare the first factor. It's not that difficult. So it's less than if argument 1 is less than the argument 1 of the other one. The product is argument 1 times argument 2. If the it's always a type, so if argument 1 or the argument 1 type rather is less than, between quotes, arg2 type, then it's definitely less than, right? I mean, whatever you want. This as long as it has a unique ordering. But if that is not the case, then it's still less than if argument 1 type is actually equal, which means that it's not the other way around. And something more. The other way around, meaning if we get here, then this is not true, which means that E1 is not less than E2 with respect to argument 1. And if argument if argument 1 is also not less than, well, the other way around, then it must be equal. And then we can look at argument 2, right? Going to try to compile this because I added so much. Something has to give in. Nested name specifier is less constant enumerator denominator, constant enumerator denominator. What the hell is that? No, call on too much. Holy moly, I did it a few times more. I'm so totally going senile here, it's unbelievable. This is downright scary. Well, I copied it every time, so maybe I only made this mistake once and then blindly copied it. Let's hope so. Template argument for template type. Parameter must be a type. Yes, I meant that, yes, I meant that. Type name. So arg1 type is, well, a type. And e1 is a template parameter, then you have to put type name in front of it, otherwise the compiler doesn't know that. Well, it would know time it instantiates it, but it wants to know earlier. Expected function style cost. Okay, num loss. What is this? Oh, yeah, there. Is less v. Is less is just a struct, but we need the value type of it. Then you get a boolean. Otherwise, you do a requires for a class instead of a boolean expression. Class template partial specialization is not more specialized than a primary template. Definitely not true. Yeah, okay, I can't do that, I guess. A product type is a kind of absolutely random type with certain requires as well. I mean, it's a concept. But apparently it's not more general than an expression. So the is less is defined as expression, comma expression. And I'm trying to specialize it now with extra requirements, but it is apparently not allowed. So instead, I'll have to say that it is a product right here, as in product something. Which means we have 4 bloody expressions. And then, yeah, E1 arc1 type is now just E1. I mean, E1 is the arc1 type of the whole thing. So, just E1. And this is then E3. Yep, so either E1 is less than E3, or, well, if E3 is not less than E1, that means that they are equal, and E3 is less than E1. E4. E2 is less than E4, I mean. That one is less than that. Yeah, okay. Now, finally compile. I've deleted that thingy too much. Yeah, it compiled. Okay, now. Can still contain bugs because not instantiating a single is less. But let me add some that is lost on first. So this would be oh wait a minute, I forgot something. This is less for two products, but I'll also have to do a product and an arbitrary expression. Where the arbitrary expression is definitely not one of the things that I already defined elsewhere. So not is constant E3, and not is symbol. And not is power. What else do I have? I think that was it. Well, some product are almost the same, aren't they? Put this on the reverse and then I place product with sum. And then no, let's do it. Computer wants me to go to bed at midnight. Ha ha ha. Oh, still compiles. So I think this probably makes more sense than just comparing the range. Let me think about that. There's two ways I can sort this. I mean, in the end it gets sorted anyway, and it's compile time, so you might argue just choose the simplest code and then who cares how slow it is, basically. But maybe it helps in compile time. I don't know. If we try to do it a little bit more smarter. So if the whole range of symbols is less than the other one, I can swap both arguments. So that would be Especially if say one is a symbol and the other one is another symbol, then bang, done, you know. So range here means just the smallest and the largest symbol. I don't mean the value of the symbols, I mean the ID of the symbol. So say A till D, and then here X till Z. Yeah, so alphabetically they are larger. So if that is already the case, that argument 1 is only contains symbols that are less, or actually that would be this one. So if argument 2 contains symbols that are lexicographically smaller, well, it's the ID and not really the name, but okay. Then we have to swap them, so I would like to just swap the arguments. But yeah, it's not allowed to sum. Sum is not allowed to have a sum as first argument. So if that is the case, then I take the first argument of that sum, which is then not a sum because that was not allowed, and add the rest to the rest. So now we swapped it. Swap the two arguments in a legal way. If they do not overlap, because now this is not true, and if this is true, then we have all the non-overlapping cases covered. Then I would like to simply construct a sum without swapping anything. But in this case, still can't do that. Not allowed to put a sum here as argument 1. So again, special case, if now argument 1 is a sum, then we have to take the first argument of that sum, which is then again not a sum, and so on. It's kind of the same thing as there, but then argument 1 instead of argument 2, and argument 2 instead of argument 1. While if you try to add a 0 to it, then we ignore everything. Now, I think that this even works for when argument 2 is 0, because that is a constant, and that has a range of -1, which then always means that, well, maybe not. Okay, let's say x plus 0. So and then the ID of x is say 0, and the ID of 0 is a constant, which is -1. So then this is less than that, so we get here, and they are swapped. So I just, but that's not correct. Yeah, that I construct a sum even. That is not correct at all. You know, I'm using a plus here, so we go recursively back and then do the rest there. I'm not doing that here, which is kind of nonsensical. Because more short circuits might be needed, at least when argument 1 is a 0, then it's not correct. Is there any other reason? Wait a minute. If argument 2 is 0, that's not correct. Yeah, here argument 2 might be a constant. Even though it is not a sum, I still don't want to construct a sum that starts with 0 as a constant. So I have to do the same check here as we are doing here. If is a constant, and then I mean argument 2, we have to do something else maybe. And then the same thing here. If that constant, that is 2, is equal to 0, then ignore argument 2. And otherwise you can just do what we want. Okay, so now it works. It did indeed not work. If either is a constant, we don't get here for both being a constant. That is specialized for two constants. But if one of them is a constant, then the constant is put up front, and if unless it is 0. But that was kind of a extra work, a lot of lines I have to say. So otherwise, we get here, we have an overlapping range. In which case we might have equal range, sorry, we might have equal terms in the sum. Let's edit product again. If we compare it with multiplication, then I have here as well, if the range is just simply less, then it is not allowed to have a product as first argument. And we have to do special stuff with a constant, in this case both 0 and 1. And otherwise we can keep it. And here the other one, which cannot be a product. Which makes you wonder if not I should test here for argument 2 being. How the hell can I not have tested that? This so seriously looks like that x times 0 is not taken care of. Let me test that. Yeah, not all in let me have another look. Ah, this is just wrong. How could I get here? Well, then the second one is not a product, and I'm using it directly into a product. That's not good. Argument 1 could be a constant. Or argument 1? 2? 1 or 2? This must be true. They cannot be both, and the constant will have a lower range. So the argument 2 must be the constant. Yeah. Oh, completely impossible that I not already tested that. No, apparently I didn't. Sure. It is called by an aesthetic assertion. Product should never contain a 0 or 1 as factor. Let's edit this somewhere. Yeah, they're just constants. Yeah. Was 0 already defined here? I doubt it. It's defined here. Just move it up. Yeah, I want to test multiplication with a constant and a power too, I suppose. Times 0. It's a bit too much work to edit here, isn't it? I'm just going to return arc2 times arc1, I think. Because it doesn't really matter that arc2 is a non-product, so. So less in, etc. Yeah, okay, maybe I'd have to do this, so just tiny a little bit faster. More code, but faster in the end, I think. So we want to do argument 2 times argument 1, but if argument 2 is 1, then of course you just do argument 1. And if argument 2 is 0, then the result is just 0. Too many arguments. You're calling me, kidding me. Actually, I solved that in all the other cases by introducing some constants. So 3 divided by 2 is not an, what am I doing here? Oh, it is an exponent. Okay. Anyway, const expression. 3 halves. The macro didn't like it that I have a comma there. I had a comma there. So it's not gonna like this comma either, of course. I have to remove all of them. X to the power 3 halves times 1 times 0 times, yeah, there's one more, okay. Error in the valid operand, so binary expression. Constant and constants. Oh. It is the 10th time that I made that mistake. The precedence of the caret is low. Stupidly low. Everything works. Okay, the next the product, which is finished. Haha, I just fixed it. Make sure that the one with the smallest first factor is put first. So we can do that with sum as well. Let me just copy this. I'll look at that later. I'll just delete it. So if this the range is less, the range begin is less of 2, then we want 2 first. Even the comment is correct. Then the next block is if the first thing is an argument, sorry, the first thing is a product here, which is not allowed, and the second one is a constant, a symbol or power, What's happening here? Yeah, just strip off the first one because this is a product. Why does it matter that? Oh right, yeah. I can't do if both are a product, and the compiler was complaining. So this deals with one being a product and the other one not. And then two products are done here and other operators. There's something I don't understand here. Make power should only be called for constants and a symbol, or a symbol and or a power of the same symbol. How the hell is this guaranteeing me that this is the same symbol? It's not. Don't see it anyway. But it says so here. A in both cases. Make power demands it as well, I think. But you know, it in order to get there, in order to make it legal to call make power, these two must be the same. I guess overlapping ranges means probably. No, it doesn't. Even x times y. Say we have x times, well wait a minute, if I have x times y, then I have a non-overlapping range. It must be an overlapping range. So we could do x times d. Argument 1 is x times d, and argument 2 is y times c. So y and c fall within x and d. Why am I saying d? That's a times d, and then times b times c. So bc is both in between a and d. So if this range is a to d and this range is b to c, then it is overlapping. Therefore we get here. And then the beginning of the range, of this range, is b, and this was A. So this is not true. So we get here. And both are products. Oh, wait a minute. That's a trick, maybe. So this was a product, okay. But if this is not product, oh yeah. Okay, I'm finally getting it. If one of them is a symbol or power, that means a single symbol, and it overlaps, then it must be equal, because a symbol is just a single thing, can only overlap when it is equal. I'm still not convinced, actually. I need a pin. I need a piece of pen here, piece of paper. Okay, let's make a symbol. Yeah, argument 2 is a symbol. Let's say B. And then the first argument must be a product. Let's say A times C. So if you have the product A times C, and then we multiply that with B. Then the range of the first one is AC, which is not less than B, because it overlaps. Same here. So we do get here. And this was B, is not less than A. So we get here. And this is a product, A times C, and the other one is a symbol. So we get here. Oh wait, we get here. I wanted to get here. Okay, so I need the first one to be... First one must be a symbol which is less than the product. Which is, yeah, okay, finally I'm getting it. Okay, yeah. Okay, I'm getting it. Maybe I should add a comment here. This big power allowing constants. 2 constants. No, it must be exactly the same. So it's 2 constants. So that argument 1 is a single range means is because of the fact that it is a constant or a symbol or a power. So that's the first line. Then this quote here is this demand, which means that it's not this, so it's larger or equal. So the first this just means that the symbol used in argument 1 of argument 2, that's the beginning of E1, is greater or equal than the single ID of argument 1. Well, then it could still be that it is not equal, of course. Could be larger than. So I need another demand. I'm still missing something. Yeah, but it can't be larger. If it was larger, then the whole range would be larger, because this is a single range thingy. So the important thing here is that it is not the case that the whole range is larger. So this is false. Yeah, it's still not very clear, but if anyone ever, I mean, it's not trivial, but if it's enough comment for someone to be able to figure it out, I think. Maybe it's too specific for product. Let me just go to the sum. Okay, I think the reasoning here was that if they overlap, that means that argument 2 has a range that starts with something that is in the middle of argument 1 and argument 2 of argument 1. So by putting argument 2 here, we would get the correct ordering if this was a single symbol. And otherwise, more arranging is done. It's got to be inserting it in the middle. However, this is totally different now. Now it's a sum. I mean, again, it's not allowed to construct a sum where the first argument is the sum itself. So definitely need to special case it if argument 1 is a sum. And then I just basically just want to take the first term of that sum, which is this one, and then add the rest. So the rest is called second term, and the second term is then argument 2 plus the rest of argument 1, which is this. But the order, yeah, I guess it doesn't really matter. Or is that wrong? anyways. What the fuck is this, man? Why is that E2? That looks totally wrong. It should be E1, shouldn't it? Huh? No, if this is a constant, and I want a special case if that is a constant. So I have to test argument 1 of E1. Why is that E2? E2. Constant. Already digested E2. It's just nonsense. Just nonsense. I'm totally okay with nonsense, I will just fix it, but I just was puzzled that my test suite didn't catch this. So I have to add a test. Test that catches this nonsense. So weird. Suppose, I think it must be E1. No, it must not. It must be E1 colon argument 1 type. And suppose that is a constant. Then this is now, I think, never going to be true, or, well, it could be true, but... Oh, that's also nice, yeah. Maybe... Yeah, wait a minute. If this is true, then I'm returning the wrong thing. Then we get the square of argument 2. So I can, if I make argument 2 is sort of a constant, so we do say times 2, and then the first argument, or this thing must be a constant as well, where argument 2 is already constant. That can only be when this is a constant. So then argument 1, argument 2 must be a constant, or something times, I don't know, 3. And we must get here in the first place, which means that this cannot be true. Sorry, yeah, this cannot be true, but it's definitely true because this is minus 1. So this is as small as it can get. This was a constant, we said. Therefore, this has to be minus 1. But if we do that, then everything is a constant. So we'll never get here. So I think this is just never true. And it should have been what I just said. So if that is the case, but we don't do this, then we do this, which also works because it's a star. That would just call operator star on constant and constant, and we don't need this at all. It's a bit scary. Let's do this like this. What can I do? Redo, undo. So I think we don't need this, which means I don't need this. And I think that the test suite still compiles and runs fine, but it doesn't. Oh, that's what? This is just how the hell can that happen? How the hell can that happen? When is this called and how is that ever correct? It's a product of a constant with a product of a symbol and a symbol. Sorry. What the? It's a product of a. No, it's yeah. Well, okay. Constant times a product of a symbol and a product again of a symbol and a symbol with a product. How the hell do we get there then? So this whole thing collapses into 0. I'm trying to multiply that with a product of a constant. These two are swapped. So this is constant times A times C times D. Product of constant times product of symbol times symbol. And then all times constant. How is that not overlapping? Overlap. This one also has constant in it. Yeah, it should overlap. It does overlap. That's why we get here. Duh. Okay, so it's a product of a constant, blah blah blah, and the other one is just a constant, argument 2. So we could try here a non-constant. This is say a constant, and this is a non-constant. I don't think it matters much. Meaning, I'll test it. Let's put in front of this. No, that is a bit too much. Let's take a real constant. And here also a constant times some variable. I'll use A. So that worked, I think. Oh wait, too few arguments. Totally did not work. The result of that should be 4 times A. Nope, it's not triggering it. Okay, what about 2 times B? No, I'm just trying things. Still not. What was the problem now? Which one was the problem? Oh, this one. Let's make it more look like that. Constant something. Yep, now it's triggered. Now obviously that's the same as using a 1 here, right? And then obviously that's the same as using 0 here, which should exist. And now you're telling me that is not the same as just multiplying with 0? No, it is. Okay. So let's keep it at this: constant times symbol times constant. Or maybe I didn't try 0. So what if we use 2? Then it did not trigger, right? It has to be 0. Yep, no, it does not trigger. Special case, special case, 0. Okay, so both contains constants, so it's an overlapping range, so these two is not true. We get here. Well, this range is just containing -1 for the 0. And this is -1 till that constant. So it's not less than. Wait, it's begin. Yeah. But still, -1 is not less than -1. So we get here, and then the first one is indeed a product, and the second one is a constant. So we get here. And then I'm lost again, because I thought we were going to get it somewhere else or not. No, this is the one. Yeah. That was the problem. This is definitely the problem, because it says in all caps we get here. How late is it? Bedtime, I guess. Is yeah. So now we get 0 times the second argument. Ah, that's a symbol. It's not a constant. If it were both constants, then we would not have gotten here. We do get here for this being a constant and this being a symbol, which then does not lead to 2 constants. Never, ever, 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 ever. Unless E2 is a constant, which it is. But this would never be a constant. Because, I mean, non-zero times a symbol is a symbol times it, but it's just not a constant. Argument 2 could also be the inverse of this symbol. Okay, anyway, being 0, yeah, that gives a constant. So now we are both constants. And that has to be special cased because this won't compile. Can't construct a constant from the non-const expression things that we have here. Function parameters. Oh, wait a minute. So the E2 was wrong, right? Well, the E2 is wrong. But this is only going to be a constant, or this, well, the type of that, if that one is 0. So the result is still 0. I'm going to change this, really. This should have been E1 argument 1 type with the type name in front of it. Comment is yeah, this is a mind-boggling difficult again. I just figured it out, I think. Yeah, well, one of the cases was when argument is 2 is 0, but there must be another way. I think if we make these two each other's inverse or something, let's say x times y times x to the power minus 1. And that would also overlap. Let's try that one. So first this must still work despite the E1 argument 1 type change. Can't find it. Oh. Okay, I give up. I guess I didn't fill that in. It's of course correct. 2 times a times 0. So I think that we can still get there as well by doing, say, x times y times, I'll put parentheses around it even though it's not necessary. Y post. So I want to get here, but not for I don't want to assert when I already know that it happens, which means when argument 2 is 0. But let's see, 2 is 0. Okay, 2 may not be 0, but still this is true. No member is 0 in symbolic symbol. Ugh. Not even really interested in any concept for that matter. No. Like that. Uh-oh. Yeah. This is not true, of course. Well, I don't know. Seems like then we can only get here when it is equal to 0. Might as well return 0 then. Jesus, this is way too difficult. I'll leave it like this. This should work now, so... Not that I am capable of running the test suit, but... Okay. So that was working on the bloody sum. Not sure this is even possible then. I guess this could be the negative of that one, and then you also get 0. Yeah, stuff like that. But in this case, oh wait a minute, so this is the same, right? So it has to be E1 argument one time. Which assumes that I can't do this. Well, why would I not be able to do that? That would be a constant plus a constant, so I can't construct a sum from two constants. Well, I should be able to. Sum in a line, constant expression sum. I don't know, man. No, wait a minute. That's not true. If we are here, man, what a nonsense. I can't do a plus for two constants? Of course I can do a plus for two constants. What's the problem with the product again then? Oh, because the operator star is overloaded for two constants. Constant.h operator star const, that's a const evil, that's why it's not possible. God knows why. Only we had an AI that could code. And that's also conceivable as well. Unless the conceivable is just bullshit, which actually feels like it. Then this is necessary. Otherwise, might as well do that. So here we make progress because if E1 is a sum, I'm splitting off the first argument and then it's no longer a sum. Because now we have, well, E1 is no longer a sum, this is not a sum. So the whole thing is recursive, but it's kind of like a tree. It's no, there is no loop or something. So there must always be a finish. Now, despite the rearranging, it might still be overlapping, but then we would get at least here then. Or something, one of the other things. Plus, of course, this recursive call is shorter because, well, a part has been cut off here. And then maybe I can do something like if E2 is a sum, let me do something special. Otherwise, neither argument 1 nor argument 2 are a sum, and then I can have to just even create a sum. Unless argument 1 and argument 2 are the same type. Then I want to return a product 2 times argument 1. They are the same. Or they could also be the same for, but from a factor, but that would be a product, to be honest. Well, they could both be products of, yeah, the argument 1 and argument 2 could be a product, so that's not a sum. But it could be a product of a constant with something that is the same for both. And then I can just add the constants. I'm not sure I even need this part. Yep, I think I need to do the following. Cons expression is less. Let's do 1. Kind of defeats this test here. Isn't this just correct to create a sum if neither is a sum? And E2 is less than E1, and this is how I want to create my sum. I think that is correct. Else, if, oh, get all the ifs. Else if E1 is less than E2, we do that. Else, they are equal. Yeah, but this is not what I want. These bloody things can still exist, can still be products with that start with a constant. Yeah, it's not good. This is not good. I think it's time to go to bed. It's too late. We'll continue this tomorrow. Okay, good night.